today's video, we're gonna do some experimenting with all these chemicals to see which one is the best electrolyte. I don't even have all the different ones here that you could use as an electrolyte, but I have the three most common ones and then some other things like a strong acid and some strong bases that the internet just said could be an electrolyte, but I'm not sure anyone's ever used it for wood burning. And also gonna use some electrolytes that you take for your body at the end of the video just to see, because it's a mix of different salts. So right now I got some baking soda here that I'm weighing out, and trying to get, I think I'm gonna use 10 grams per 100 milliliters for most of these. I think that different concentrations work better with different electrolytes, and finding that information quickly was not super easy. So I decided to just kind of make up a number that was close to what I found for baking soda. We're using sodium bicarbonate as the first one because it's the one that I've had the most success with. So we're mixing that up right now, and we're going to pour each one in these cups. I think, just turn the mixing up here a little bit, get that going faster. And essentially, usually you'll spray the electrolyte over the wood as you burn it, but in this case, I don't have 7 different spray bottles, so I'm not gonna do it that way. I'm just gonna put the electrolyte in a cup, and I'm gonna dump it on the wood, try to dump the same amount on each piece of wood. I'm using maple ply here. Every strip of wood is the same size roughly, and from the same sheet of plywood. So it's somewhat of a controlled experiment, but also I'm not really a scientist or a chemist or anything like that. So this is, gonna make those kind of people cringe. Anyway, I'm gonna get a close-up here so you can see what's happening with the wood burning as we do this first sample here. All right, so we got our first sample here, sodium bicarbonate, baking soda. As I said before, I did just 10 grams per 100 milliliters. I'll go ahead and turn the stirring off here and pour this into my cup carefully and make sure that the stir bar does not come out. Okay. So, as I said before, normally you would spray the electrolyte over the workpiece, but in this case I'm just going to pour it. Probably don't need the resistive gloves insulated gloves for this aspect, but let's just pour this on here, kind of soak it in, let it soak in here a little bit. Okay. All right, so there we go. That's the sodium bicarb. Okay, I'm gonna get to the exciting part here. Grab these here wands. Nothing's got electricity yet because my foot is not on the plug. So I'm not really sure it's gonna work this way, but let's give it a test. Let's hold them far away and see what happens here. Okay. Trying to find a path. Got a long way to go. I'm also using my lower powered burner just because I'm only on a 15 amp circuit and I don't want to blow the circuit. I got other things going on here. That's looking pretty cool. It's kind of burning under the surface. And it is working its way across. See if it ends up making it to the other side here. Wasn't really planning on doing it for this far. Probably going to be burning the plastic underneath this. Yeah, it's going. I mean, there's no doubt about that. It is going. All right, we're gonna call that good. We're gonna call that good. So that's, boy, is that bright too. Don't think that these goggles even really work well enough with that. So here we have it. The first piece, sodium bicarbonate. This is, as I said, the one I have the most success with. So next we'll do borax. Okay, so next we're gonna try some borax. Going to rinse out this baking soda. Just throw it in this bucket here. Retrieve my magnetic stirrer. Okay. And to this we will add 100 milliliters of water. This is just filtered water. It's not distilled water, and distilled water would be ideal for this. But that's not what I'm doing here. So we're looking to get 10 grams of this white powder here called borax. It's 6.3. Oh boy, that's a little bit much. Okay, so I'm gonna just dump this in here and let the stirring commence. Yeah, it looks pretty mixed. So I'm gonna pour that on here once again. Kind of let it soak in. This may not work at all because maybe I'm not using enough borax. Now all of these electrolyte solutions, yes, that really didn't mix that well. Let's just add a little bit more water to this and let it mix while we're doing this and just see what happens. Okay, here we go. Oh, wow. That is a very pretty fractal. Very delicate, very small, branching a lot. Oh wow, that is cool. I think this borax is one of the more popular ones for people to use. That is amazing. Look at it just grow and grow and grow. That is a very nice one. Wow. Okay. Wow. I think that's enough. I think that's good enough for that one. That's very cool. Very cool. Once again, that was at a lower concentration than suggested on the internet. So potentially that has to do with why it's so delicate. But yeah, that's super cool. And I think I misspoke. I think borax actually has 2 sodium molecules per or atoms per ion per molecule. Yes, it does. Borax has 2 sodium atoms per molecule, so more conductive. I have no idea what I'm talking about if you can't tell. So this is hydrochloric acid. I think it's 30%, but the SDS said it was 10 to 30%, which is a wide range. Hard to work with that number, but this is what we got. And this stuff is very caustic. It smells really bad. It's super dangerous, very corrosive. You don't want to get this on your hands or in your eyes or any of that stuff. So I'm going to be very careful with it, putting on some gloves. And I'm also going to wear this face mask because it really does smell absolutely terrible. This is in a liquid form. It's already in a solution. Like I said, I think it's a 30% solution. It's typically what they come in. So, all right. So that's 50 mils of the stuff. There's a lot of articles. All kinds of interesting things happen with hydrochloric acid and wood
Not really going to go into that in this video, but I will get a close-up of this. Okay, hydrochloric acid, here we go. Let's dump this on here. Oh wow, there's a lot of hair in that beaker. You can see it reacting with the sodium bicarbonate, which is of course to be expected. And maybe that wasn't enough, you know? But this stuff's going to be popping and splattering all over the place. So I just want to try a little bit to begin with. So much for the control numbers. And here we go. This would be the probably one of the least user-friendly electrolyte solutions to use. It looks like it's already staining the wood and everything. So let's see what we got. Holy mackerel. What is going on there? Okay, let's get these probes a little bit closer together and see what happens. Interesting. Just burning circles. Wow. Not sure what to make of that. Looks like it's transmitting down to the wood because I have all those other electrolytes at the bottom there. I don't think this works very well. It's just burning the other electrolytes from the bottom. So, let's say, you know, those are the sodium bicarb and the borax burning there. I would say that the hydrochloric acid is not a very good electrolyte. At least not this one. At least not at 30% or whatever. What I do have now is hydrochloric acid just chilling in here, which I really don't want. So I'm going to do a little bit more on here just to see what happens. These are not the right gloves for this. Okay. I'm going to put this cap on. Alright, so that's that. Pour this in here. Actually, what the hell? Just pour it right on here. Really let this soak in. So when the hydrochloric acid reacts with the baking soda, it actually turns into salt and a sodium chloride and hydrogen gas, which is explosive. So maybe that's what's happening. These little things just blowing up right there. Also, the salt is still conductive, so you know, even if all the sodium bicarb gets reacted with the hydrochloric acid, it's still going to be salt, which is still conductive. Interesting. Okay. Kind of done with that one. Alright, that's hydrochloric acid. I'm going to let this salt water continue to warm up. I'm going to set this aside so we can look at it later. And I'm going to clean up this mess and this acid because I don't really want that on here. I'm going to dry this up because it's affecting the results, and we'll be back here in a few minutes. Alright, so we're back, and now we're going to try
the salt. This is one of the more popular electrolytes to use with wood burning. I'm just going to take it off the stirrer here. I think it's had plenty of time to stir and dissolve. Should be fairly concentrated. Need to find, it's very warm. Need to find my glasses to protect me. Okay. Got my glasses on. I'm just gonna pour this over here just like before. And in the past, I've made some very concentrated saltwater solutions and had zero luck getting it to burn. Obviously, I'm doing something wrong because people use saltwater solutions all the time for this. So let's see what happens here. This is once just like all the other ones, 10 grams per 100 milliliters. I heated it up. I let it mix for quite a while, and it should be very salty. So let's see what happens. Get these back on here. Put my face protection away, face shield. Okay. Just try far away like all the rest, and we're gonna go ahead and put the power on. Fizzled out. This is kind of what's happened in the past. I'm not sure what I'm doing wrong here. Let's go a little bit closer. It kind of wants to burn. Doesn't really seem like it's transmitting the electricity very well. It's still trying though. It's definitely still trying. Not really what I'm looking for though. Let's get a little closer here. There it goes. Okay. Very poppy, crackly, snappy, crackly, poppy. Getting there though. It's making a path. It's yeah, it's kind of working. Definitely not my favorite so far though. See what happens if we try this again. I feel like maybe I just it didn't soak in enough on that end. This end is still very wet with it. Also, those leaves are super close, so don't really want to do that. Yeah, well, that's it for the salt. I must be doing something wrong there. Let's take this out and add it to our pile. Alright, let's see what's next. Ooh, sodium hydroxide. You know what? Let's save that one for next after next and do potassium hydroxide next, because that is already in solution, whereas the sodium hydroxide I need to mix. So we will mix up the sodium hydroxide and then we will burn the potassium hydroxide. I'm gonna put on my protective wear again because sodium hydroxide is another one of those things that is very dangerous. Very, very, very dangerous. So I will put on my mask and my gloves. We'll measure out a little bit of that sodium hydroxide. Boy, this is getting to be a long video. I'm glad I did the good ones first. Well, I really don't know what these last ones are going to be like. I've never done them before. Just probably going to be a lot like the strong acid. Alright, so we got some
lye crystals here, aka sodium hydroxide. Oh boy, there's all kinds of stuff in there. I don't know what's going on with that. But at any rate, we're gonna measure out 10 grams of it, put it in some water. That's what we're gonna do. We got all kinds of stuff here. The SDS said it was just sodium hydroxide. So, I don't know. It looks very colorful. It's some kind of weird stuff going on there. I'll post the SDS information in the description along with everything that I've used here. Alright, set that up to 100 milliliters. I'll go ahead and dump this in there. And turn on the stirring. Oh boy. Sketchy stuff. Get that in a little waste bucket over here. Alright, so now for this stuff, potassium hydroxide, I'm going to do the same thing with this. Probably ought to, before I open this and get into this, probably ought to clean the acid out of my graduated because I don't want them to react while I'm pouring it in. Okay, so this stuff is also very caustic, very poisonous, very dangerous. Just going to dump, oh boy, I'm going to dump 50 ml in here. My graduated cylinder, and pour it on here and burn it. See what we get here. Potassium hydroxide. Just really want this to soak in, which apparently it's just gonna all pour off of there. Well, that's not really the best situation, but let's give it a go. Alright, potassium hydroxide, burning. Whoa. What? That is crazy. Holy mackerel. Wow. Okay. So that's intense. Also, in doing that, it's popping and splattering and getting potassium hydroxide everywhere. This is not good. I would not recommend that, but wow. What an effect. What an effect. Holy mackerel. I have to clean all these off and show them at the end of the video, but yeah, okay. So that's that. Impressive. Very impressive. That was a powerful burn. Okay, and this here sodium hydroxide is not really mixing too well. Let's turn up the stirring, see what happens. There we go. Maybe it needs a little heat, I don't know. Let's get into the sodium hydroxide. I think it's mixed well enough. Let's go get this video rolling. It's been long enough here. Alright, turn the stirring down. Dump this out right here. Still got all those weird things in there. Maybe they just don't dissolve. They're not dissolvable. Let's see what happens here. Let's try to pour most of it over here since it wants to trail down that way. Let me just get this on here. In a future video, I hope to test even more electrolytes, different ones, things like potassium chloride and calcium chloride and things like that. But let's see, here we go, sodium hydroxide. Okay, it's getting a little close to my mic. I don't really like that. This is also seems to be a very powerful electrolyte, conducting quite a bit of electricity in this wood here, current. Yeah, it's working well. Okay, I think that's enough of that. Wow. Okay, take a look really quick. Wow, that just burnt the hell out of that. Holy crap. Okay. Once again, we'll take a look at all these at the end of the video here. Just have one last one, which I need to prepare. So I'm going to take a short break and we'll be back.
All right, well, thanks for hanging in there with me. The last thing we got here are these electrolyte tabs that you take for, or these chewable tabs. You take them for your, to have electrolytes in your system. So we're just gonna stir this up, and as I prepare this solution, I'm actually just gonna pop one of these in my mouth real quick because I need some more electrolytes in my system. Ironically, wood is a plant, and we all know that plants crave electrolytes, so I'm gonna see how this goes, but it might take a while for them to dissolve, so in the meantime, just going to show the results that we've gotten so far. So the very first one we did was this sodium bicarbonate. This is baking soda. This is the one that I use the most often, as I've said like 100 times. And we got some pretty nice results. Starts out real deep. It's kind of burning under the veneer a bit here. And it goes out, and there's a lot of branches, and it's a pretty nice look. I'll show some close-ups of this for you. And the next one we did here was Borax. This one was amazing. Never got Borax to work before. I was clearly doing something wrong. But yeah, it had all these tiny little fractals that just kind of went everywhere, and I was really happy with the results I got from that one. So that was Borax. And then I think after Borax we did, what did we do? After Borax we did hydrochloric acid, I think. Here we are. The hydrochloric acid one, still wet with acid, of course, as I touch it with my bare hands. Now this one had these weird circular burns. I'm not exactly sure what was happening there, but let's get this out of the way. But yeah, it kind of burned over here a little bit. I don't know, wasn't really super impressed with it. I imagine the hydrogen that was being formed was igniting around it from the sodium bicarb. What's interesting, down here we have some burns where the current was being conducted underneath the piece via the hydrochloric acid that was dripping off the side into the sodium bicarb, and that was creating these fractals here. So that's another interesting phenomenon. Maybe in the future when I test other ones, I will neutralize some hydrochloric acid with some sodium bicarb and see how that burns as an electrolyte. Next we have salt. This is just sodium chloride, basic table salt. Didn't really work that great for me. Never has. I probably just am not making a strong enough solution, or it's too strong. I don't really know what I'm doing here. So that was the sodium chloride. And after that we have the potassium hydroxide. That thing, whew, that burned hot. That just peeled everything off here. That was kind of crazy, kind of violent. Would not recommend using any of these super harmful, super caustic chemicals for wood burning. And then lastly here we have the sodium hydroxide, which was also kind of like the potassium hydroxide, no surprise there. And it burned really deep and really hot and really well, actually. It's a very interesting pattern. It's almost like a, I don't know what that is. It just removed so much material. It's unreal. So that's kind of a cool one. And you can hear that thing still kind of kicking around in there, but I think it might be ready to do a test. Dissolved enough to do a test. So let's get a close-up and burn this. Alright, once again we just have some of these salt stick electrolytes. These are actually really expensive and they're very tasty. 10 out of 10 would recommend, but we're going to go ahead and pour that electrolyte solution on here and see what we get. It's what plants crave. It's what wood burners crave, electrolytes. I imagine it's a mix of all different types of chloride salts, potassium chloride, sodium chloride, calcium chloride, etc., etc., etc. Also, I mean, I don't even know if it really mixed in there well enough. It might not do anything. We'll just put that back on the stirrer for stirring's sake. Okay, here we go. Contact. Kind of anticlimactic. It's about the same as the salt, it seems like. Let's get these probes a little closer. There we go. Oh, there we go. Seems to be doing something there. I'd say maybe even better than the table salt, sodium chloride. Look at it go! Wow, it's actually it's cool. It's really cool. It has some pretty delicate features there. I'm liking that one. It's very expensive way to burn wood. And you can buy all those salts in a much cheaper form. This is, expensive because it's chewable and probably for reasons that don't matter. But there we have it. That is just the electrolytes. That's cool. I'm a fan of that. I will never do this again, of course, because